Welcome to lesson 4.3. It's about population mean estimation for large samples. And our memory verse today is found in Leviticus 27, verse 16. It says, "And if a man shall sanctify unto the Lord some part of a field of his possession, then thy estimation shall be according to the seed thereof. An omer of barley seed shall be valued at 50 shekels of silver." Now, you see, estimation doesn't only happen in the modern days. Even in the Bible times, estimation is still present. Now, at the end of this lesson, we'll be able to identify appropriate form of confidence interval estimator. Again, when we say estimator, it means formula. The answer is what we call the estimate. So estimator for a formula, estimate is the numerical value. Next, we compute for the confidence interval estimate. Then we solve problems involving confidence interval estimation. And the last, we draw a conclusion about the population mean. Now, having bear in mind that this is for large samples. So we ask, when is it large and when is it small? Now, let's have the venture with me. We have the wait time case. Susan, a TLE researcher, looked at the average time in minutes it takes a random sample of customers to be served in a restaurant. From 20 customers, the following information was obtained. The question is, what is the average wait time? Then you need to answer this main question. Based on the average wait time, will you recommend the restaurant? Why or why not? So I look forward to your answers in our online classroom. Now, there are 4 steps in computing for the interval estimate. You might ask, "Ma'am, why don't we compute it right away?" Actually, we can, but to show you the logical procedure, we'll do it step by step. Now, the first step is we describe the parameter of interest. If we ask what is the parameter of interest, it will ask you, what is the problem all about? Now, since we are making an estimate for the population mean, so your parameter of interest should start with mean. Mean what? Average what? If we go back to our venture activity, what is our parameter of interest? It's about the average time or the average wait time in a restaurant. You say mean or you say average. So here we say mean scores of grade 11 students. Then step 2. In step 2, I made a mnemonic. It's A, T, C. A for assumption, T for test statistic, and C for level of confidence. Now, how do ma'am, is it necessary that step 1 should be in a sentence? It can be in a sentence or it can be in a phrase like mean score. That it ends there. The next one. For the assumption, you really need to have it in a sentence. Now, when the sample size is 30 or more, again, when the sample size is 30 or more, it's for large samples. If it's less than 30, the sample size is small. Now, how do we state our assumption for large samples? This one. Actually, you can copy paste. Just change the one with the underline. We say the sample size of 50 is large enough. Thus, the central limit theorem holds and the sampling distribution of means is normal. We need to assume that it's normal or normally distributed, or else we could not make an estimate. Next, test statistic. If the sample size is large, then we use the test statistic Z, or we call it the Z test. Next, the level of confidence. I told you there are three common. We have 99%. So our alpha, or the level of significance, is 0.01. If the level of confidence is 95%, our alpha, or our level of significance, is 0.05. For 90%, it's 0.10. Next, in step 3, we have the GPE. G stands for given and PE for point estimate. So what can you check for the given? The sample size, or the N, the mean, the X bar or the mu, and the standard deviation, the sigma or the S. Then we have the point estimate. Remember in chapter 3, lesson 2, in sampling distribution, it states that the point estimate is equal to the sample or the population mean. The next, confidence coefficients. We have this last meeting. Then the margin of error. Then what's next? The upper and the lower confidence limits, or sometimes we call it the upper and the lower interval. And then we interpret and describe the results. Example. The purchasing officer of a Yuda company needs to estimate the mean lifetime of batteries. He randomly selected 40 batteries from the delivery that indicates a sample average life, an average sample life of 360 hours. The supplier stated the standard deviation is known to be 100 hours. Help the purchasing manager set up a 90% confidence interval estimate of the population mean life of batteries. Let's start. Parameter of interest. What is the problem all about? It's about the average or the mean lifetime of batteries. Step 2. How many samples are there? He randomly selected 40 batteries. So 40 is a large sample size. So we say the sample size of 40 batteries is large enough. Thus, the central limit theorem holds and the sampling distribution of means is normal. And since this is large, our test statistic is Z. Our confidence level is 90%, so our alpha is 0.10. Next, let's have the given. What's the given? Average sample life. That's the X bar, 360. Our N is 40. Our standard deviation is 100 hours. The point estimate is equal to the sample mean. So our point estimate is still here. Oops. That is still 360 hours. Next, confidence coefficients. At 90% confidence level, our confidence coefficients are plus and minus 1.65. Actually, you need to memorize it. This is a two-tailed. So for two-tailed, for 99%, that's 2.58. For 95%, that's 1.96. And for 90%, that's plus and minus 1.65. So that's 1.65 times 100. That's our standard deviation over square root of 40. The answer is 26.09. Next, the lower limit You subtract it from your sample mean. The answer is 333.91. Ma'am, how many decimal places? Last session, I told you that the number of decimal places depends upon the number of decimal places of the sample mean, as long as it won't be the same. So example, the sample mean is a whole number. So your upper and lower confidence limits must be whole numbers also. So 334. For the upper limit, you add, that is 386. So how do we describe and interpret the result? We say the purchasing manager is 90% confident that the average lifetime of batteries ranges from 334 to 386 hours. Now, what if the problem does not state that it's the purchasing manager or the purchasing officer? Like you say, the company needs to estimate without telling who is the one deciding. So you just say it this way. We are 90% confident that the average lifetime of batteries ranges from 334 to 386 hours. That's how you state it. Let's go to problem number 2. A researcher wants to estimate the number of hours that 5-year-old children spend watching television. A sample of 55-year-old children was observed to have a mean viewing time of 3 hours. The population is normally distributed with a population standard deviation of 0.5 hours. At 95% confidence level, find the interval estimate of the population mean. Now, what is the problem all about? It's about the average TV viewing time of 5-year-old children. Why do we need to state 5-year-old children? Because the problem does not state just children. It's specific on, diba? Remember in your practical research one, you need to state your sample size specifically. Who are the audience? These are 5-year-old children. These are children, or say in your research, these are OFW children. So we need to state specifically. But ma'am, what if I place there mean viewing time of 50 5-year-old children? That will be wrong. Why? In the parameter of interest, you should not write the sample size. Why? Because we are making an estimation for the population. And if you say state 50, it would mean that we only make the estimate in the sample size. So do not state the sample size in the parameter of interest. You just say mean viewing time of 5-year-old children. And what's our sample size? 50. So it's large. So how do you assume? A sample size of 50 is large enough. Thus, the central limit theorem holds and the sampling distribution of means is normal. And since this is large, our test statistic is z-test. Our confidence level is 95%, so our alpha is 0.05. Another question. Ma'am, what if there's no confidence level? Then you set your confidence level. How do you do it? Actually, I told you there are 3 famous confidence levels in stat, but basically there are only 2 that is acceptable when we do the statistical analysis. It could only be 99% or 95%. When do we decide it to be 95? Any problem, the acceptable range is 95%. But if the problem is a medical problem and it's about a drug or any medical analysis, it should be 99%. Why should it be 99%? Here, how will you feel if the researcher will say that they are 95% sure of the COVID-19 vaccine? That's alarming, right? So that's why we raise the confidence level for medical problems. Because when it involves life or death, then we need to raise it in the highest standard that we can. So we say they should be 99% sure that the vaccine works. I remember the advertisement for Safeguard. It kills 99.99% germs. That's how we do it when it's a medical problem. Next, step 3, GPE. Given our sample size is 50, the mean viewing time is 3 hours, then our population standard deviation is 0.5 hours. And remember, the point estimate is equal to the sample mean. So our point estimate is 3 hours. At 95% confidence level, our confidence coefficients, also called as critical values, are plus and minus 1.96. We solve for the margin of error. That's 1.96 times 0.5 over square root of 50. The answer is 0.14. Then we subtract it from our sample mean. The answer is 2.86. We subtract it from we add it from our sample mean. Our upper limit is 3.14. Now you might ask, ma'am, the point estimate here is a whole number. Why is it that our upper and lower limits are not whole numbers? Why? Because if I'll round this off, it becomes 3. If I round the other one off, it's still 3. So it does not make any sense to say that the range is in 3, which is also the point estimate. So when problems like this arise, have it to 2 decimal places. So how do we state our results? We say the researcher is 95% confident that the mean viewing time of 5-year-old children ranges from 2.86 to 3.14 hours. So that's the end of our lesson. Number 3, it's just the same with problems 1 and 2. So I think you can manage it well. The only difference is here, the point estimate is a whole number. That's why our lower and upper limit are also whole numbers. So you'll have 2 problems for today. Activity 1, let's see, and activity 2. The given are all complete.